Hi, this is Bill Bond. In this video I'm going to talk about how to use the Hazus model for hurricane wind. I've basically broken up hurricane into two different videos, one where I focus on the wind, one where I focus on the surge. I know some folks aren't interested in surge, they may be more inland, so they're only really the wind model is the only one relevant for them. So I'm going to go ahead and get started. I'm going to create a wind region in Virginia on the coastline. Basically I've selected Virginia Beach. I'm going to go ahead and create a new region. I'm going to call it Virginia Beach Hurricane Flood. So HU is hurricane, FL is flood. And I'm going to click on next here. And I'm going to select both flood and hurricane. So this is a pretty common issue I see in a lot of mitigation plans that I've reviewed in the past. People will only click hurricane here and not flood. If you only click hurricane here, your analysis will only be conducted at the census tract level. It will not be conducted at the census block level. So what that means is when you run the analysis and you get your results, you'll only be able to report those results at the census tract level. In a lot of smaller jurisdictions that are smaller than a county, like a town or township, you basically won't be able to get results for those areas because your level of analysis is just too big. So I'm going to select both of those. I'm going to click on next, and then I'm going to select county, click on next again, and I'm going to select Virginia and Virginia Beach. Next and finish. Okay, so now it's going to pull that data from my state data set into my new study region called Virginia Beach HUFL. That new study region folder will be created in my Hazus data folder. So we'll just take a few minutes to do that. Okay, so that took a few minutes. It took a little bit longer because I'm bringing in both the flood and the hurricane information into the study region. So I'm going to go ahead and click OK here. I'm going to go ahead and click Open a Region, click OK, click Next, and I'm going to select the region I just created. I'm going to go to the hurricane model and then click Finish. Okay, so I've just opened the study region. You'll notice it takes a little bit longer to open the regions in the hurricane model. What happens is the model generates all these layers here on the left, so you have all these different return periods. Okay, so for all these 7 different return period events, we have wind speeds for those. We have a roughness layer as well that gets created, which I'll talk about a little bit later. So we have all of these different things going on in the during study region opening, so that's why it takes a little bit longer to generate. Okay, so like flood and earthquake, we have inventory, hazard analysis, and results up here. Our inventory is focused on the hurricane inventory. You'll see it's similar to the other models. We have general building stock, so this is the data that's aggregated at the census tract or block level. Now because I create a flood hurricane region, when I start to open these tables, you'll notice that all the data is at the census block level. Okay, so I mentioned this when we created the study region. The data, the inventory data, the analysis will all be done at the census block level. It's much easier to define a jurisdiction with census blocks rather than census tracts, which are based on population size. Okay, so we have specific occupancy here. We can look at building types as well. We have the general occupancy, so similar to the earthquake model. We have buildings and we have contents, and then we also have total. Okay, so we can look at the data that way. Again, this data is aggregated at census block level. We can look at the square footage, we can look at the building counts, and the dollar exposure. So 3 different ways to look at the data. You know, how much square footage are in each building, in each census block, the building counts, and then what is the replacement value of those structures. So again, we're talking about replacement value here. We're not talking about market value. So keep that in mind as well. It's just how much is it going to cost to replace a structure if it's destroyed. Okay, we also have mapping here as well, which I'll talk about in a different video, but we do have a way to map the general building types. So how do we go from our general building types to our specific building types, from our occupancies to our building types. So we have to kind of understand that. So we can view these as well if we click on view. And we can see for a residential 1, which is a single family home, in this particular area it's about 75% wood, 25% masonry in our general building stock. Okay, so this is based on this VA1 scheme name. Okay, then we also have the specific building type mapping. So how do we go into the specifics of our building types? Okay, so we have 8 different categories in the mainland United States. Hawaii has its own categories as well. So we can look at, in our case, we're in the southeast coastal area. We can look at that. So let's see what we are in. We click on Virginia Beach, it should come up here on the right. So we're actually in the northeast. Virginia is considered the northeast coastal. So we click on northeast coastal, we can view that. So we can see within wood our single family homes. Okay, 59% are WSF1, 42 are WSF2. Okay, if you ever want to know what that means, we can go down to inventory and view classification, and we can look at our building types here. So WSF1, it's wood, 1 story. This one is 2 or more stories. Okay, so that's how it's broken up. And then you'll see that the hurricane model gets into a lot of detail here in our wind building characteristics. So again, we have all these different scheme names here. Northeast coastal. If you look at that and we view it, and I'm just going to click on the little plus sign there, look at a single family home. So you can see we have roof shapes, hip versus gable type, secondary water resistance, how many of our structures have that, the roof deck attachment, so this is 8 versus 6 pane nails at different spacings, and we have a roof wall connection as well. So how many hurricane straps are we using versus just a toenail connection. And then we have garage houses with shutters, I'm sorry, without shutters and with shutters, and these are all percentages basically. How many of our homes actually have shutters? Okay, so by default it says 2%. And within the model, one thing nice is if you don't agree with these percentages, or you have better data, you can actually come in and you can make a copy and start editing that copy. So you can actually change those percentages to better reflect your community. So I'll talk about how to do that in a different video. I'm just going to hit cancel here. You also have the ability to mitigate too. So if you do want to show what mitigation will do for your losses, so you can calculate things like losses avoided, you can do that as well by clicking on the mitigate button and mitigating certain things like adding shutters, adding secondary water resistance, that sort of thing. The only thing it doesn't provide you is the cost of doing that. So I'm going to hit cancel here. The other inventory we have is our site-specific inventory. So if we go down to essential facilities, we can look at our inventory. And this again is going to look like the other models, earthquake and flood. We have our 5 different essential facility types: medical care, our hospitals, fire stations, police stations, emergency response centers, emergency operations centers, and schools. are here as well. If you want to see where those are located, you just click on map and then OK. Okay, so we can see where those are located. We can verify them, make sure they're still there. Maybe there's some new schools that need to be added. So we can always do that when you start going through this process. You'll want to verify the inventory. This is from the federal government, the Highfield data set. So that's where Hazus is pulling this information from. Under inventory, we also have the ability to we can map high potential loss facilities, so nuclear facilities. The dams and levees are no longer there. Actually, the nuclear facilities have been removed. So this is really just a placeholder if you want to add this, but the hurricane model will not actually provide losses to it, so it's not really worth it. We also have hazmat facilities here as well, so we can look at that. So this comes from the EPA's Toxic Release Inventory database, and we have our different chemicals here and the quantities of them. You'll see that in some locations the address is the same, so each record here represents a different chemical, not a different address. So you'll see the first, looks like 6 here, all correspond to one address. The next 2 correspond to one address. So really we have 3 addresses here with 9 different chemicals. Okay, you can map these as well. So you're going to hit cancel here. And then under inventory we have user defined facilities. So this is empty for most of the US. There's a couple of locations on the west coast where this is pre-populated, but those areas don't support the hurricane analysis. But you can add your own buildings here. So if you do want to do a site specific analysis, you can do that. And then we also have our transportation systems. So highway, railway, light rail, bus, port, ferry, and airports. And all these have drop downs. So you can again map those, make sure that you've got everything there. I will tell you, you also have utility systems here that you can map as well. I will tell you though, under our results here, you'll see it's pretty limited. We have our general building stock results, we have our essential facility results, we have our user defined facility results. Okay, so we have no utility results here, and we have no transportation results here either. So the hurricane wind model is lacking in those results. It's not as complete as the other models. So keep that in mind. You may want to add some of these as user defined facilities and model them individually. But I will warn you, if you actually look at the result tables, we haven't run the analysis yet, so it's going to warn me that these are not up to date. But you'll see that really you have limited results here. You have damage state probability. So this is going to tell you what probability this structure is going to be for damage. So if it has a 20% probability of minor damage and 30% for moderate and whatever percent for severe, and then destruction. And then you have another no damage probability as well. So those combined should equal 100%. Okay, so just keep that in mind. It's pretty limited. You don't have a dollar loss like you do with the flood model. It is a little bit different in this analysis. Also, you don't have the loss of use that you would in the earthquake model. Okay, then we also have debris and shelter in the results too. So in the hurricane model, we can do several different scenarios though. If we go to hazard and scenario, this basically walks us through how to set up a scenario. And there's different ways we can set up a scenario. So when we first create our first study region, you'll see that you only have really 3 selections here. So just kind of ignore these. These are created for other applications. So we have the probabilistic event, and basically this will allow you to run the hurricane model's version of the probabilistic event, which is a little bit different than the earthquakes. And I'll talk about that just in a minute here. We also have a historic event that we could do as well. So if there's been a historic event, I'll click on next here. It takes me to the historical event database. So it lists all the historical events in that database, including some more recent ones here as well. And you'll see you'll see the hurricanes that have impacted your specific region by clicking on basically the region filter here. Okay, and then it'll kind of show you which ones have impacted your area, and you could select these and then click on next, and you'll see what those look like. So what I can do here, let me go ahead and select Hurricane Donna, and I'll click on next. I'll click on next again. I'll make this scenario active, and I'll click on finish here. So at this point I can go to analysis and click on run, and I can run the Hurricane Donna storm. Okay, so this is pretty interesting to do when you are looking at some of the more historic events. So of course all of our coastal areas around the country have been built up over the last several decades. So some of these events have occurred 50 years ago or 40 years ago. It's kind of interesting to see what those events would do with today's infrastructure. It's really easy for people to understand a historic event as well, since it's already occurred in the area. They might remember it. So you could do that as well, and kind of see what the damage and loss is going to be with that event today. So those are different ways of looking at these historic events. They're pretty interesting to see in some cases. You go ahead and click on next here as well. I can also create a new scenario. If I hit create new scenario and click on next, there's a couple of options here for me. So I can define my own storm track manually. So I need to be able to characterize the storm. So if I click on next here, it'll ask me for a scenario name. This is fine. I'll click on next. Now it's going to ask me what data I have. So the first one here is going to ask me whether I want to plug in times. So I need to identify the hurricanes, basically the eye of the hurricane at certain times, or the translation speed of the hurricane as well. So the location, at that location, how fast is the hurricane moving? Is it moving 20 miles an hour? Is it moving 25 miles an hour? I need to input those speeds. So this is either or, so times or translation speeds. Next thing I need to have are the radius to maximum winds or the radius to 64, 50, and 34 knot winds. Okay, so depending on what my source is, I may have one of these data sets that I need to supply Hazus. And the last thing is the maximum wind speeds or profile parameter. So if I have the maximum wind speeds, I plug that in, or if I have the Holland profile parameter, I would use that instead. Okay, so once I have this selected to where I want it, I click on next, and then I plug those values in. So here's my latitude and longitude, here's that speed, translation speed, radius to max winds, max wind speed, and then the central pressure as well is required. Once the hurricane has crossed into the land, I would select inland. And then I also have the ability to add a forecast event as well. So you'll see that when a hurricane is actually developing out in the ocean and coming in, FEMA will actually use this software to predict what the losses are going to be. So what you could do is add your known characteristics here, and then once you get to a forecast event, click on forecast, and then there's some uncertainty associated with that next forecast. So you could do that as well. Okay, so I'm going to hit cancel here. I'm not going to run my own event. Okay, if I go back to hazard and scenario, click on next, click on create new scenario, click next. Okay, I can also import from an export file. So if I have a colleague who has developed their own storm event, I can import that here. I can also import a census tract data file. So what this is basically you have a data set that has your census tracts, and it has a wind speed associated with that census tract. So you can bring that data in, so it's not an actual census or not an actual hurricane track coming in, it's just a wind speed applied to the inventory in that census tract. We can also import hurricane storm advisory as well. So if we click on that and click on next, this is the easiest way to bring in a storm advisory. We have to define whether it's an Atlantic or Pacific event, and if it's just been uploaded to the HurVac FTP website, we would click download here, we would browse to it, and we would bring in the data. Okay, so that's about the easiest way to bring in a storm as it's developing, is to use the HurVac website and download the storm directly. Okay, and then the last one is the probabilistic model. Okay, so the probabilistic model, basically what that does is there's a database in the software that has a great deal of storms modeled in it. So what happens is there is basically that database of 100,000 years worth of storm events in the software, and it basically takes all those tracks and it looks at your study region, and it selects all the tracks that impact your study region, and it selects the event that is going to cause the 1% loss, or the 0.02% loss, or the 0.2% loss for your area as your 100 and 500 year event. It goes 10, 20, 50, 100, 200, 500, and 1,000 year. So those are the 7 return periods, but it is based on the loss. Okay, so it's different than the data that's over here in your table of contents. Okay, so if I click on this 500 year return period, and I right click and I hit label, kind of take a look at these wind speeds, and I zoom in here. So again, this is by census tract, and if you recall, if you saw the video on the earthquake model, this is similar to how the earthquake model does probabilistic. Is it basically would just take these wind speeds and would apply it to your inventory in your study region to get the losses. But that basically generates a lot of similar loss throughout your study region. So in this case, you can have more loss here on the coastline and less loss here in the interior. What the hurricane model does is it actually, when you run the analysis, it actually places a hurricane track through your study region or next to your study region, and it runs the event in that area. So you may have, if your storm is up here in the north, you're going to have more damage up here in the north than you would in the south. Okay, so that doesn't mean that your critical infrastructure down here is less likely to be damaged. It just means that that event was selected as the probabilistic loss event. Okay, so taking all those losses into consideration, that's how that event is selected. So just keep that in mind. If you have a really large study region, if you're doing like the state of Florida, you're going to end up with some parts of that state getting no damage and some parts getting a lot of damage, depending on what event gets selected for these different return periods. Okay, so you'll end up with 7 different events that get selected to generate those losses. Okay, so this is different than the earthquake model. Now, if we want to do a similar analysis to the earthquake model, if we want to just apply these values, and these values are actually used for the building codes in this region. So they are the ASCE 7 publication building codes. We can basically use that. If we go to hazard and scenario and go to create a new scenario, we can actually use that with the import census tract data file, HWIN file. So we could use this methodology to show what would happen with doing a probabilistic scenario similar to that of the earthquake model. Okay, and I'll show you how to do that in a future video. Okay, so one thing I am going to warn you about, because I did create a study region that is both flood and earthquake, my analysis, this probabilistic analysis, is going to take quite a while. Okay, because all the analysis is done at the census block level and not the tract level. Okay, so I've set this up for a probabilistic analysis, and what I'm going to do is go to analysis and run. Now there's a couple of options here. One is doing the user supplied coastal surge grid. Because I selected both flood and hurricane for my study region, I can run a surge as well. So the benefits of running that surge with the wind is that I can combine the losses at the end. Hazus has a methodology where it combines the flood loss and the wind loss into a total loss for my general building stock. Okay, so this allows me to not double count the damage. So if a structure is damaged 75% from the wind and 50% from the flood, I don't want to add those two numbers together to get 125% damage. Okay, I'm never going to get more than 100% damage. So the methodology that Hazus uses combines those losses into one result that does not double count the damage. Okay, so it does the analysis at the subassembly level at the building for the building and combines those subassembly losses together, and then we end up with a total loss at the end. Okay, and there's more detail in the technical manual for the hurricane model. Okay, the other thing is I have the ability to set the optimization analysis mode. It is set to off. So if I, for some reason, wanted to do the analysis at the census tract level, I can click on this and change it from off to on. Okay, so if that is on, then my analysis will be done at the census tract level. I don't want to do that though, because I want to look at my neighborhood level losses. Okay, then I also have my user supplied coastal surge grid. So I have the ability to bring in my own surge grid. So if I've created my own surge grid, or I have a NOAA product that I want to bring into the software, I can do that by selecting this to yes, and then I would have to supply the coastal surge grid in the flood model, and so I'll talk about that in a different video. Okay, so I'm going to click on run here, and I want all the direct physical damage to my general building stock and my essential facilities, my user-defined buildings. I don't have any of those, but I'll just keep that clicked. I do want to, I've got my direct social loss. I'm not going to select automated output options. You'll see that you can actually create your own reports and maps. And when you're doing this quickly, if you've got a hurricane event coming in real time and you're trying to get maps and reports out very quickly, some people will select this option just to make it easier. What happens is you define where Hazus is going to put these reports and maps, which folder it's going to be, and then select the maps and reports that get generated, and it creates those automatically with the analysis. So you can just go straight to that folder and send them off. You'll also notice here I do not have an option for surge. Okay, I don't have an option for surge because I have selected a probabilistic analysis. Okay, the probabilistic analysis is one of the few analysis that does not support surge. So keep that in mind as well. I can't do a surge analysis with probabilistic. I have to do a deterministic event. Okay, so it's got to be a historical event or an event I create myself. But again, it's got to be a deterministic event in order to do the surge analysis as well. So I'm going to go ahead and I'm going to click on run analysis here, and then I'm going to pause this video because it will take quite a while to complete. Okay, so that took about 5 hours to complete. So you'll see that because, again, we went at the census block level instead of census tract level, it took hours instead of minutes. So I'm just going to click OK here. Alright, so now I should, under my results, I should have all the results for all the different probabilistic analysis. So it's a little bit different than the earthquake model or the flood model in that it runs all the probabilistic analysis at the same time. It also includes the average annual loss as well. So if I go to my storm track, like I mentioned earlier, there's a separate storm track for each of these events, and those storm tracks produce the 100% or the 100-year loss event or the 500-year loss event. So we click on that. We may need to zoom out a little bit to see some of the tracks. Some may not go directly through the study region. Just going to zoom out just a little bit here. So you see this heavy black line here. So that's where the 500-year event went. It actually went south of the study region through, it looks like, North Carolina and then up. And we can actually go and take a look at some of the wind speeds generated from that event as well. So if we want to do the 500-year, we can map that. Then we click on close. And I'll refresh. Okay, so you can see from the map the higher wind speeds are in the south where the track went through. And then there's not as high wind speeds in the north. Okay, so you can see that 112 or so here, and then up goes up 107, 105, 106 up here. Okay, so now if I look at the 1,000-year, the 100-year, those numbers may be reversed. The track might have gone through the north here, and maybe you have higher wind speeds up here and lower down here. So it all depends on where that track goes. And just remember that when you look at the losses, it's looking at those losses as a total when the model selects that storm event. Okay, so we could also look at our economic loss here by occupancy or by building type. And again, I've got my different return periods here. And then I also have my annualized loss down here as well. So if I want to look at that, I can look at that as well. Okay, so let's say my 500-year event, I can click on total, and I can click on map. I'll close this up. And I will go ahead and remove my wind speeds. Okay, so you start to see my losses here. And again, you've got losses now at the census block level, not the census tract level, so it's much easier for me to query out these losses for jurisdictions smaller than a county. So if I have a neighborhood map of Virginia Beach, I can add that. I'm just going to hit add data here. I've got some administrative boundaries I'm going to bring in. I just downloaded from their local website. So if I want to know my losses for a specific neighborhood, just going to open the attribute table here. So I've got one polygon, precinct 2, beat 220, so it's a police beat. So within this neighborhood, you see I've got this one selected, and what I can do is I can go to selection, select by location, and what I'm going to do is just select my total losses, and it's going to be within that boundary layer. So everything gets selected in that boundary layer, that one neighborhood selected. What I usually do for here, for the spatial selection methodology, is I have their centroid in the source layer feature. There's other ways you can do it as well. It does take just checking at the end to make sure that it looks okay. And I'm going to click OK. And I'm going to remove some of these other census tracts and boundaries just so it's not as confusing. Okay, so now I can see I've got all those census blocks selected that are inside my neighborhood. And now if I look at my attribute table, okay, you'll see 340 are selected. I can just click on the show selected records. So these are the ones that are selected here. And if I want to know the total loss, I can right click here and go to statistics, and I can look at my losses here. Okay, so this is in thousands of dollars, so keep that in mind. This actually tells you up here in the top. This is a nice feature of the hurricane model. It's not in the flood or earthquake models. So I know that this is actually $110 million of damage. Okay, and that is just for that one jurisdiction. Okay, so we've got the losses divided into our direct losses, the buildings, the contents, the inventory, but also the business interruption losses, including relocation, income, rental, and wage losses here as well. So the total includes both those different components, all these different categories. Okay, so you can kind of see now how you can query out those neighborhood results. You no longer have to run the analysis at the tract level and say, sorry, we can't divide it up by jurisdiction. It just takes a little bit more effort. What you may want to do is run it before you leave at night, and you'll have all the results in the morning. That might be something you do instead of waiting around for 4 hours, although sometimes you can do other things while you wait. We also have the essential facility losses. So you'll see for each of our essential facilities, we have the different return period events here. See, average annualized loss is not here. So if I want to look at my 500-year event, let me just make this a little bit bigger here. I can see I've got my minor, moderate, severe, and destruction. These are my damage state probabilities. So the probability that this building, this first hospital here, okay, Centera, Princess Anne Hospital, there is a 12% probability it sustains minor damage, 12% probability it sustains moderate damage, 19% probability it sustains severe damage, and 9% probability that it's destroyed. So if you add these up and subtract them by 1, you'll get the probability of no damage at all. So that'd be none is the fifth category. It's not listed here. We also have loss of use in days. So how long will the hospital be non-operational? How long is it going to take to get going again? So if we move to a 1,000-year event here, you'll see that you start to get some loss of use here. Okay, then we also have user-defined facilities. I have not added user-defined facilities, but you'll see the only thing you're missing here is the loss of use probability. You've got the damage state probabilities here, same as the other site-specific data. So those will be listed here as well if you add the user-defined facilities. Now, one thing I will mention, although we did the analysis at the census block level, the wind speeds themselves are actually at the census tract level. So although if I click on wind speeds here, you'll see all these wind speeds assigned at the census block, but what you'll notice is they do not deviate across the tract. So all the tract values are going to be the same. So if I overlay my census tracts here, I'm going to change the symbology so you can see it better. Okay, so you can kind of see here, everything across the tract is going to have the same value. Okay, so these are all 106 all the way through here. Okay, so it's one kind of limitation of the model. All the wind speed modeling is done at the census tract level. And in some situations, you might have a large tract where the or a tract that really deviates in the environment, and you may have that may not be a great wind speed. So the wind speed is calculated at the centroid of the tract, and it's then assigned to everything within that tract. Okay, so keep that in mind when you're doing your modeling as a limitation. Okay, then we also have our debris estimates, similar to the other models. The one difference here is the vegetation. So we have our tree data. I guess I should say tree, not vegetation. So it's tree, limited to trees. And we have our two different categories here. We have our eligible and then total. So here's our total tree tonnage and cubic yards. And then here's the eligible. So what they've done is they looked at the populated areas, so areas with structures, with roads, that would need to have the trees removed after the event. So in such situations, you're going to have trees that fall in the middle of the forest and may not get removed. So what they've done is they've tried to make a subcategory of trees, and this tree debris would actually be removed after the event. So it's trees that have fallen near or around populated areas, roads, and that sort of thing. So that's one difference with this model than the other models. And again, we can look at these and we can map them. Okay, if we want to do total tree tonnage, we can map that. And again, you get the damage at the census block level. So you can again query it by your neighborhoods and see what sort of neighborhoods have the more tree debris instead of being forced to do it at the census tract level. And then we also have the shelter requirements as well. So the displaced households, again, there are several people per household. And then short-term shelter needs, this is actually the population, so the number of people. So these are not the same. This is households and this is people. Okay, looks like I'll have to increase this event size to get got a few here. So 6 here and 6 families, 3 people of those families are going to seek public shelter. And again, you can map this too, and it's by census block. And then you also have the summary reports. If I click on that, and I go to other reports, there's a global summary report for each return period. So I can click on the return period I want, and I can click on view. And it's going to take a while to create here because it's creating maps and rolling up all of those results into one report. Okay, so here is the probabilistic 500-year return period hurricane for Virginia Beach. You'll see this is similar to the other ones. We have a cover page, and we have a table of contents, describes what's in here. So we have a section on the description of the region. We have information on the inventory, the general building stock, and such facilities. We have the hurricane scenario parameters, and then we have the building loss, in the induced hurricane damage, which includes the debris generation, We have the social impacts, which are the shelter requirements, so the displaced household and shelter requirements are here, and the economic loss as well. So you can kind of go through this and see. This is again the inventory section, and here's our damage. You'll see it's mostly residential, some commercial. Okay, this is showing it the damage by the building type. And then we have our essential facility damage here as well. Our debris generation. And our shelter needs, so displaced households and temporary shelter. And then here's our economic loss as well. Okay, it creates a couple of charts for us, so we can kind of see those losses in different ways. You can see these three actually correspond to this pie chart: building, content, inventory. Inventory is just so small you can't see it, while the rest of these four are shown here for our business interruption. And you'll see all these tables and charts. They'll have the units of measure in the top as well, so that will tell you what units you're looking at. These are thousands of dollars, so it's actually 347 million here as a subtotal. And the next page should have the total. Okay, so this is $3.34 billion total loss for the area for a 500-year event. And there are other reports as well that are smaller. You have shelter requirements, all these different losses. You can look at the tables individually by clicking on View here. And again, it takes a few minutes to load as it creates the table and the results. Sometimes it creates a graphic as well. Okay, so here we go. Okay, so this is just a one pager. Again, it tells you what the units are up here. This takes a little bit less time to calculate. Also gives you a loss ratio here as well. So this is something you have to calculate by hand outside looking at the results, but looking at kind of the losses divided by the inventory will give you an idea of what the loss ratio is. So this is for, I believe, the 10-year event. And so this is for the annualized losses, so this is going to be a pretty small number. Okay, here's a 10-year, a 20, 50, 100, 200, 500, and 1,000. Okay, so you can see that loss ratio is going up and up. Okay, so that basically covers our results for the hurricane wind model. You'll see that we have combined wind and surge loss here, which is not available until I actually run the surge and then run the analysis to combine the two losses. So we're looking at strictly the wind damage, not the surge damage. So this area, if a hurricane hits it directly, it will have a lot of surge damage as well. So it's something we need to take into account. And I've got another video that where I kind of focus on the surge and how to integrate that into the model. So hopefully you'll watch that as well. So with that, that is it for the hurricane wind model. And I've got several other videos that go into a little bit more detail on some of the more advanced aspects of the model that you're welcome to watch as well. Thank you.